Welcome to this video. The main focus of discussion in this video is irrational numbers. Discussion in this video. Number 1. Are the numerator and the denominator of fraction always integer? Number 2. Square root spiral of positive integer and irrational numbers. Number 3. Classification of non-terminating decimals. Number 4. How to find irrational numbers. And lastly, number 5. Classification of irrational numbers. Let's start with the definition of irrational number. A real number, not expressible as an integer or quotient of integers, is known as irrational number. In other words, we can say a number cannot be expressed in the form p by q where pq belongs to z of integer, that is pq or integer, and q not equal to 0 is called an irrational number. Now let's go to the next topics. Are the numerator and the denominator of fraction always integer? No. There are many fractions whose numerator and the denominator is non-integer. If the numerator and the denominator of fraction are integer, that is a rational fraction. In this case, we can call the number is a rational number. If the numerator and the denominator of any fraction is non-integer, that case some are rational and some are irrational fractions. Or we can say some are rational number and some are irrational number. The example of rational fractions are 1 by 2, 3 by 2, 5 by 6, etc. In all the cases, the numerator and the denominator are integer. Some fractions where the numerator and the denominator are non-integer. 5 by 2, square root of 8 divided by square root of 2, square root of 5 divided by square root of 6, square root of 3 divided by square root of 2. In the first case, pi divided by 2 is a fraction. We know pi is the ratio of circumference and the diameter of any circle, and pi by 2 is a fraction. In this fraction, the numerator is non-integer. In the second case, square root of 8 divided by square root of 2, both the numerator and the denominator are non-integer. In the third case, square root of 5 divided by 6, here the numerator is non-integer but the denominator is integer. Lastly, square root of 3 divided by square root of 2, here both the numerator and the denominator are non-integer. Now let's see in which case the numerator and the denominator are non-integer but the fraction is still rational. This one, that is the second case, square root of 8 divided by square root of 2. Here the numerator and the denominator both are non-integer but still the fraction is a rational fraction, or we can say this one is a rational number. Other than this one, the other fraction are irrational fraction, or we can say irrational number. Let's see how this number is a rational fraction. Square root of 8 divided by square root of 2. If we simplify this, we can write square root of 8 divided by 2, and after simplification we can write square root of 4 divided by 1, and finally 2 divided by 1. The fraction where the numerator and the denominator both are integer. So these are the rational fraction. So we can say the square root of 8 divided by square root of 2 is a rational fraction, or we can say this one is a rational number. Now, square root spiral. This square root spiral is a very interesting presentation of number with the help of geometry. If we consider a right angle triangle of two equal sides of length 1, then the hypotenuse of that triangle will be the square root of 2. Again, if we consider this hypotenuse of length square root of 2 as one side of another right angle triangle, where the other side is again 1, then we will get the length of hypotenuse of that right angle triangle is square root of 3. In this way, every time if we consider the hypotenuse and the side perpendicular to that hypotenuse of length 1, every time we get the square root of another integer as new hypotenuse. If we consider this square root of 3 as one side of a new right angle triangle and another side perpendicular to this square root of 3 is 1, then the new hypotenuse will be square root of 4. In this way, if we consider another side that is 1, then the new hypotenuse will be square root of 5. In this way, we can easily get the square root of positive integer number as a hypotenuse of this right angle triangle. The visual presentation of this all right angle triangle looks like a spiral, which is known as square root spiral. The square root spiral is a very interesting application of Pythagoras theorem in number. With this square root spiral, we can get square root of positive integer up to infinity. The square root of positive integer is either a positive integer or an irrational number, but never non-integral rational number. Now let's see what is non-integral rational number. A non-integral rational number is a fraction where numerator and denominator cannot be cancelled to leave an integer value. The example is 4 by 8, 1 by 2. We can express every integer as a fraction where denominator is 1. Other than this integer, all the fraction which cannot simplify to integer is non-integral rational numbers. There is some connection between the previous statement and this square root spiral. The circle marked roots are irrational numbers. So we can say this square root of 2, square root of 3, square root of 5, square root of 6, square root of 7, square root of 8, square root of 10, square root of 11, and up to this one is square root of 15 and square root of 17. These are irrational numbers. Other than this number, that is 1, this square root of 4, the square root of 9, and square root of 16, these are the positive integer in this case. The square root of all positive integer other than the perfect square is irrational number. Let's see the square root spiral again. Here we can easily see this square root of 4, square root of 9, and square root of 16 are positive integers. Other than these, other numbers are irrational numbers. So this 4, this 9, and this 16 are perfect square number. That's why square root of this perfect square is a rational number, or we can say a positive integer. So we can say square root of all positive integer other than the perfect square is irrational number. This is one of the way to find the irrational number. Decimal numbers which have infinite number of digits after the decimal point is called non-terminating decimal numbers. Example 3.14159 and dot dot dot. Non-terminating decimal numbers are of two kinds. One, recurring or repeating. Number two, non-recurring or non-repeating. Non-terminating repeating decimal numbers. The example is 3.123. Here, this 1, 2, 3. These are the repeated here. That is 1, 2, 3. Again 1, 2, 3. So we can say this 3.123, 1, 2, 3, and dot dot dot. This one as a non-terminating repeating decimal. Again, the non-terminating, non-repeating decimal numbers. Example 3.12342359. Here, after decimal point, no number is repeated here. That's why this number is example of non-terminating, non-repeating decimal numbers. these non-terminating, non-repeating decimals are irrational numbers. So this is another way of finding the irrational number. That is, we can say non-terminating, non-repeating decimal numbers are irrational. Example 3.12342359 dot dot dot. Now let's see way to identify irrational numbers. Number 1, in case of positive integer, square root of non-perfect square numbers are irrational. Number 2, in case of decimal fraction, non-terminating, non-repeating decimal fraction numbers are irrational. Number 3, in case of fraction, non-integer fraction till last simplified form are irrational. Now, square root of 2, square root of 3, square root of 5, square root of 101. In all these cases, the numbers with this square root are non-perfect square. That's why these are the irrational numbers. Now, 1.122, and dot dot dot. That is 2.71828 dot dot dot. 3.14159 dot dot dot. In all these cases, these are the non-terminating, non-repeating decimal. That's why these are irrational numbers. Square root of 2 divided by 3, square root of 7 divided by square root of 3, pi divided by 3, e divided by 2. In all the case, these are the non-integer fraction till last simplified form. That's why all are irrational. Now, the classification of irrational numbers. First one is algebraic irrational numbers. That is square root of 2, square root of 2 divided by 3, 1 by root over 3, etc. And the second category is transcendental numbers. That is pi, e. Now, what is algebraic irrational numbers? The irrational number which are a root of polynomial equation with rational coefficient. For this equation, x square minus 2 equal to 0, the coefficient here are rational. One of the root of this equation is x equal to square root of 2. So we can get this square root of 2 from this polynomial equation of rational coefficient. So we can say this square root of 2 is an irrational number and it is a root of equation with rational coefficient. So square root of 2 is algebraic irrational. Transcendental numbers. The irrational numbers which are not root of polynomial equation with rational coefficient. For the equation pi x minus y square equal to 0, here the coefficient non-rational. That is, the coefficients are irrational. The root of this equation is x equal to pi. So pi is an irrational number, but it is the root of a equation with irrational coefficient. That is, we cannot get this pi as a root of polynomial equation with rational coefficient. So pi is not algebraic irrational. We can call pi is transcendental numbers.